Hey everybody, so this is Deep Sky Stacker. This is the software that we use to put together all of our individual frames into those longer ones. And I'm going to show y'all some of the settings and stuff running through some of the images on the Eagle Nebula that I took the other night. So we're going to open picture files up here in the top left. I've separated out all of my lights, darks, and biases into little other folders so that we can get this done quickly. So do that, it'll open up. Then we're going to add our darks right there, our bias files right there. If you have flats, you can add them here too. I don't normally take flats though, so, whoops, that's the flats button. Here we go, darks. So select all of our darks, like so. Biases, just like that. And it'll show all of your files that you just added here. It's your lights, your darks, and your biases. Your biases and your darks should already be checked, but your lights might not be. That's because it wants to give you the option to exclude or include certain ones. I've already gone through and curated a bunch of my light ones, so I've taken out all of the sort of worst ones. So we are just going to hit check all right here on the left, and then register check pictures. So you want to you don't necessarily need to register already registered images. I've already registered some of these, and for the sake of this video we're going to hit that, so we do register them again, but you want to leave that checked. Automatic detection of hot pixels, you definitely want that because cameras build those up over time and you want to make sure that those don't just blot out in your image. So stack after registering, this is normally 80%, but since I went through and took out a bunch of the worst frames in my like light frame setup, I already bumped this up to 90. Going through advanced, so this is your star detection threshold. This is a very important variable for Deep Sky Stacker. So the lower the percentage on here, so 2% is the lowest, 98% is the highest. The lower the setting, the more stars that it's going to, or the more how should I say it? The more liberally it's going to determine what a star is. So if you pick a low star threshold, it's going to find more stars, but it's also going to count things that stars that may have some star trailing or a little bit of aberration on them. So there's a little bit of give and take here in that if you have more stars, it's going to stack more accurately across the entire image. But if you do that at the same time, you might incorporate some of the worst frames that you may not necessarily want. Like if you have a bunch of really crisp frames and you have a bunch of kind of okay frames, you might want to just use the crisp frames. And this in combination with that percentage, the 80-90% from earlier, is sort of how you control that. A little thing about this, you can hit that to compute the number of stars in a sample image. For this, it's 733. So 733 is really good. It's really high up there. The minimum that Deep Sky Stacker needs is 12 stars in order to stack images together. If it's not above 12, above or equal 12, then it's not going to be able to stack the image. So you want this generally high. I just have a tendency to leave this at 2% because there's a bit of tweaking that goes into every individual image if you want to try and find that sweet spot for the number of frames that you want. But at the same time, if you are excluding frames, you're also missing out on some of that time that you spent out imaging as well. So just some things that you probably should consider with that. Reducing the noise filter reducing the noise via median filter. I've tried this with it on and off, and I haven't seen a major difference, so I just leave it at the default, which is on. Recommended settings. Generally, it just prompts you for it asks you a few questions here, and if it applies to you, then you hit the option and it'll highlight in green. A bunch of these don't necessarily apply, like since the imaging you're doing is probably not narrowband, you're not going to be using channel background calibration or anything, but just read the little things and click them. Sometimes it'll be an option, auto adaptive versus Sigma, etc. I've gone through a little bit of this, and it doesn't seem like there's a really big difference in some of the ways that you do this, so just don't pay too much mind to this page. The more important stuff is in stacking parameters. So actually the recommended kind of covers these other tabs. Results is the one that you really need to look at. All right, so this preview allows you to see sort of what the different modes are. So you have standard, where you select a reference frame and it'll only shoot the interior of that reference frame. So if you have things like the movement for rotation that leads certain frames to being out, then it's not going to include the exterior. It'll just be that reference frame. If you hit mosaic, it'll include everything, all the frames, regardless of if they fit within that reference frame or not. You actually don't specify a reference frame if you're using mosaic, but and then intersection is just only the things in common for all the frames. So this is good for really small objects like the Whirlpool Nebula that I showed in one of the other videos, because that's really small and really well defined and it would always be in frame. So that was a good idea for that. And then you come on to drizzle. Now drizzle will take up a lot of additional space whenever it's processing. It's really good to use for the images because it sort of refines the stars and makes everything a bit neater. But that space is going to be an issue for a lot of people. With 2 times drizzle, it's not too bad, but with 3 times drizzle, the amount of temporary space that you're going to be writing to is ludicrous. So we'll show you that in just a minute, but align RGB channels in the final image. You can do this. You can align them later on your own. You can mess with curves in post-processing, just sort of generally. So I don't usually hit that. Reduce worker threads priority. I haven't really experimented with that at all. It's default unchecked, so I just sort of left it that way. And use all available processors, yeah. Since this is the only thing that's running whenever I'm actually running this. So you set your temporary folder. So this is the drive that I have dedicated for the image processing. It's a SSD. And real quick, the SSDs aren't supposed to be written to a ton of the time. But if you have a SSD that you can use as sort of a dedicated image processing storage, then it is a great idea, because using an SSD greatly improves the speed at which you're going to be doing this compared to an HDD. Like this set of images, which is about it's going to be about 3 hours of total aggregate time in combination with the 3 hours of aggregate time with the lights, and then a little more with the darks and biases. But that 3 hours of aggregate time is probably going to be processed in about 3 hours, if not a little bit more, with the SSD on my laptop, which has a Core i5. But if you used a HDD, it is going to be way slower. It's going to take like half a day at least. So if you have an SSD and you're willing to use it for this, then I say go for it. So we hit OK here. OK again. Oh, yep. So it gives you a little overview of some of the settings that you want. I don't want intersection, so this is a good spot to check where your settings are currently at. So we want mosaic, drizzle 2, everything good. Yep, 3 hours and 5 minutes of total time. Just goes over some of the settings. Your bias frames, we're taking it this exposure time. Your darks, we're taking it this exposure time. Your darks should match your lights, because in order for the Deep Sky Stacker software to use the darks, they have to match the lights, in the sense that the darks are meant to give Deep Sky Stacker a idea of the noise for that specific exposure time. There are ways to incorporate different exposure lights and darks sort of together, but you have to pair them at the same time. So maybe we'll have another video on that later. I don't know, but just going down a little bit more. So the process is going to temporarily use a little bit over, because this is just an estimate, but a little bit over 167 gigabytes, which is well below our 418 approximately free. You want a good amount of space in between that, because this is an estimate, and generally speaking, this is the kind of process that you just hit run on and you let it go, and you come back in a few hours and look at the result. But if you are too close to this and you actually bump over and it runs out of space, then it's going to prompt you to change some sort of settings. And if you're not at your computer, you're not going to know that. So in order to avoid anything like that, you probably want to stay clear of your highest limit there. So we're going to hit OK. So it's going to start stacking everything. So it's going to go through a few steps. It's going to make a master offset frame for biases. It's going to make a master dark frame. It's going to register all of the individual light frames. It is going to compute the stacking information for all of the individual light frames, and then it's going to compute the final image. The last three steps there, the registering, computing of stacking, and computing of the final image, are the ones that take the longest. They're about equal in length. For this stack in particular, it's probably going to be just over an hour for each of those. Maybe about an hour for each of those steps. So in about 3 hours, maybe a little bit longer, we will come back and check the results out. So I will see you guys then. And we're back. So it's been a little over 3 hours, and we have our preview right here with all of our data in. Here's our histogram. So we're going to start messing with the histogram now, just under the level. So we're going to click link settings and grab one of these triangles and move it over. So we're going to be stretching that data on the histogram out further. Apply, it'll kind of reset the triangles a little bit. I'm still going to stretch it a little further. Once you can apply, it'll update your preview, so you can start seeing a little bit of the stuff on there right now. About there is good. We're going to want to move the middle triangles over now a little bit. That moves the curves on the histogram, like position-wise, instead of stretching them out. So something over more like that. I normally bump the saturation up by 20%, which helps us get our color in there. And hit apply, so we get something that looks a little more like that. You can see some of the pillars in there right now. You can generally just sort of mess around with luminance and stuff here a little bit. You can also opt to do this in a program afterwards, like raw therapy and stuff. Photoshop, if you have it, would be more optimal. There are some other features here, like star masks and whatnot, but they're more advanced. And all you need to know to get started is this basic kind of process here. It's like we're going to move things over just a tiny bit more. Apply. Oh, that's a little bit far. There's a back button, which is kind of helpful if you go too far. As well as a reset, so maybe more like that. Yeah, if that would, oh yeah, there it is. Slightly. But anyways, this is pretty much the Deep Sky Stacker process. Whenever you're done and say, oh yeah, I like this version, you just hit save picture to file. You can also save the Deep Sky Stacker like file itself, as opposed to just the image. So you can just hit save to file, whatever you want. Generally, you want the TIFF image and everything. These files can get pretty big, on the order of multiple gigabytes. So you may want to compress them down later through via screen caps or just whatnot. But this is pretty much the process for everything. So I hope you all found that informative, and good luck with the software. See you guys.